So here we're looking at 9.4, some worked examples throughout the worksheet. And so we're looking at factoring to solve. So we looked at solving by graphing, solving by square root. So now we're going to talk about factoring to solve. And we've actually done this from the first semester. So hopefully doing enough of this refreshes your memory. So the first problem we're going to look at is number 1. And in reality, this problem is already factored for you. So all we really need to do is use the zero product property. We're going to take each of these quantities and we're going to set them equal to 0. And then we're going to solve them separately. So once we have each of the quantities set equal to 0, we're going to solve. So for the first one, we'll subtract 6. We've got y equals negative 6. For the second one, we would add 4. And we're going to get y equals positive 4. So these would be our two solutions. All right, and so remember with quadratics, we can get 1, 2, or no solutions, but in this case, because we're factoring, we're probably going to get 1 or 2 solutions. The next example we want to look at is example 4. It's already been factored for us, so we're going to take 8t minus 7 and set equal to 0, and 3t plus 5 set equal to 0. So with this, we're then going to solve each for t. So for the first one, I'll add 7 to the other side. I've got 8t equals 7. Then I'll divide by 8. And I've got t equals 7/8. Then I go about solving the right quantity. So I'll subtract 5. So 3t equals negative 5. Divide by 3. And so t is going to equal negative 5/3. So question 6, same idea. We're going to set each portion of this equal to 0 and see what we have. That includes this piece here. We're going to take 3m and set it equal to 0. And then we're going to take 2m plus 9 equal to 0. So for 3m, you divide by 3. M is going to be 0 because anything divided by 0 divided by anything is 0. For example 2, we're going to subtract, or the second set here, we're going to subtract 9. We've got 2m equals negative 9. Then we're going to divide by 2. And we've got m equals negative 4.5. And so for these examples, what we've seen so far is that they're already solved or already factored for us. So we're just setting each piece equal to 0 using what they call the zero product property. And so now let's try some where we actually have to factor. So the first one we actually have to factor is question 7. And so as we notice here that this problem has a leading coefficient of 1. So what this means is to factor this, we're going to look for two numbers that multiply to be negative 15, but add to be a positive 2. Well, I know that the factors here are going to be positive 5 and negative 3. So my factored form looks like this. And so now once I have the factored form, we're going to set each piece equal to 0 and solve. So here we'll subtract 5. So in this problem, we get n equals negative 5. Then here we'll add 3. And so n's going to equal a positive 3. And so these are our two solutions. So it's the same thing we were doing, except the previous problem started here and had us solve, but this time we had to get there on our own. Keep in mind that there are two types of factoring. So we saw the quick form, and now we're looking at a form where our leading coefficient is a number greater than 1. So in this case, our leading coefficient is a 3. So factor this, we have to use slide divide. So we're going to slide the 3 back, and it changes our problem. b squared plus 7b minus 18 equals 0. So two numbers that multiply to be negative 18 but add to be a positive 7. Well, that's going to be, it's going to be b plus 9 and b minus 2. Together they multiply to be negative 18, but they add to be a positive 7. So now what I need to do is I need to divide by my leading coefficient, because remember, this is slide, divide, and then the last part of it's called bottoms up. So we're going to try to divide by the 3. Keep in mind that if it divides evenly, go ahead and divide it. So this becomes b plus 3. Here, if it doesn't divide evenly, you bring it out in front, or bottoms up in this case. So this becomes 3b minus 2. And so now we have the factored form here, and what we need to do is set each form equal to 0 and solve. So here we'll subtract 3 on the left, and so we've got b equals negative 3. On the right piece, we'll add 2, divide by 3, and so b equals 2/3. So these are our two answers. The next problem we're going to look at is problem 13. Problem 13, notice here that this is not set equal to 0, and every other one we have has been set equal to 0. In order to solve a quadratic, whether it be graphing, square root, or anything, well, graphing or factoring, we have to have it set equal to 0. So what I need to do first is I need to move the 12. So I'm going to subtract 12 to the other side. So now my problem looks like this. And so once again, I notice that my leading coefficient in front of the w squared is a 1. So I'm looking for two numbers that multiply to be negative 12, but add to be a positive 1 in this case. So in my factored form, clearly, I've got factors of 4 and negative 3. So this becomes w plus 4, w minus 3 equals 0. So at this point, I'm going to set each of these equal to 0, and I'm going to solve for w. For w plus 4, I'll subtract 4 from both sides, and I get w equals negative 4. For w minus 3, I will add 3 to the other side, and so I'll get w equals 3. And there are my two answers. Question 15 is a special case. With this one, you still want it set equal to 0, so we're going to move the 5d to the other side by subtracting it. But when we do this, we end up with d squared minus 5d equals 0. We can't factor this the same way we factored the other ones. Instead, the only thing we can do is factor out the greatest common factor, which in this case is just the variable d. So that means we leave behind d minus 5. Well, this is our factored form, so now what we need to do is set each of these equal to 0 and solve. Well, for this first part, we know d equals 0. That's easy. Here we'll add 5, and our other answer is d equals 5. Question 12, just like the other ones, it's not set equal to 0, so we have to get it set equal to 0. So to do that, I'll subtract 7 from both sides of the problem. So that means I end up with 12y squared plus 40y minus 7 equals 0. Because of my leading coefficient of 12, I'm going to use slide divide. So I'm going to slide this back and multiply it by the negative 7. So y squared plus 40y minus, I think it's 84, equals 0. I'm looking for two numbers that multiply to be negative 84 but add to be 40. Well, that's easy. It's 42 and negative 2. So that means we've got y plus 42 and then y minus 2 equals 0. So now slide divide tells us we would divide by our leading coefficient of 12. And for this, because we're solving, we actually don't have to finish factoring this one too much. We could actually just go ahead and solve this the way it is. So instead of 42 over 12, we could just figure out what that is as a decimal. So as a decimal, that's 3.5. And then here we're going to get y minus, let's say, 1/6. I'll leave it as a fraction, a little bit easier. So technically this isn't true factoring, but it does let us solve easier. So it's saving us a step. If I'm asking for factored answers, it doesn't work, but if I'm solving, it does work. So y plus 3.5 equals 0 is going to be one of them. so we'll subtract 3.5. So y equals negative 3.5 is one answer. And then I'll do the same thing with the other quantity, which in this case is going to be y minus 1/6 equals 0. I'll add 1/6, so y equals a positive 1/6. And so these are our two answers. So the remainder of the 9.4 worksheet is your homework, but I want you to cross out number cross out number 19. So what you don't finish in class becomes homework for the 9.4 worksheet. But keep in mind you have an example of each type of factoring. Just make sure you're trying your best to complete the steps. If you need to, look back in the 9.4 folder on Schoology. Would have been from the first semester, but I'll try to keep the notes for 9.4 in this folder for today as well in case you want to reference them.